Hello friends, welcome to another video. In this video, I shall help you understand how to check measurements on instruments such as the Vernier Calipers, Micrometer screw gauge, and the meter rule. So, this is our second topic in physics after the International System of Units, which we covered in the last video. So, let us get into it. So, the topic we are going to do today is called measurement of units. So, under measurement of units, specifically we are going to look at length, because this topic covers length and then time we'll be looking at simple pendulum, but not necessarily in this video. So when we are looking at the International System of Units, friends, we said length is the total path or length taken by an object from one point to the other. Yes, the total path or length. So from this point to that point of this board, this is the total path or length, or what we call the length of this object. And we said from the first unit to say length is measured in meters. Other conversion units like the prefixes like centimeters and kilometers will have to be changed to the SI unit meters whenever you are performing calculations. Now, measurements differ. You cannot use a rule to measure how long the road is, or to measure the waist of a person, because a rule is rigid, right? There must be different instruments that can measure the length and thickness of different objects. So, what we are going to look at specifically here will be three, but let me list out some instruments or devices that we can use to find the length of an object. That is the meter rule itself. Then we have what is called a micrometer screw gauge. We have a measuring tape. We have an engineer's calipers. And then we have a Vernier calipers. Now, boys and girls, I want you to understand this. In this video particularly, or looking at the calculations that you will be asked in final exams, you will only be asked under the meter rule, micrometer screw gauge, and the and the measuring and the Vernier calipers. These others are not hard to find the length of something using these devices, and so we are not going to focus on them. Let us begin with a meter rule. Now, a meter rule is the easiest device or instrument that we can use to find the length of very small objects. Please note that if you are looking at most rules, they go up to only 30 centimeters. So you do not expect to measure a length that is more than that. And that is what we use a meter rule for. We used to find the length of books, the length of pens, pencils, and other short objects. So now, what are some of the things you must consider when taking readings using a meter rule? Remember, if you don't use precautions, you take wrong measurements. And when you're dealing with mathematics, statistics, and engineering, it is very important for you to take accurate measurements. And by so doing, you really need to know how to take these measurements. Now, what are some of the precautions that must be taken when using this meter rule? Now, let me illustrate this using an example. This is a meter rule having different values, that is the scale, And most meter rules will have inches on top, and then down there you have centimeters. So now, this is the object to be measured. The first precaution that you must take when using a meter rule to find measurements is that you must not allow a spacing between the object to be measured and the meter rule. What I mean is, you must bring this meter rule close to this object to avoid errors. Now, what type of errors are you trying to avoid? Remember, there are different ways you can view when you are trying to get the measurement. So the first precaution that you must take is to make sure the object and the rule are in contact. Another point to keep in mind is where you start your reading from. Now, most meter rules will be scaled like this. You have there is 0, 1, 2, etc., etc. So now, understand this. You cannot place an object here to be measured, starting from 1. This is what we call errors. And this type of error can lead you to finding a wrong answer, because imagine this ends up to 2.7 and you record 2.7. That will be wrong. The reason being is that when you are taking measurements, you must make sure that you are starting from 0. So the other precaution to take is to avoid the 0 error. That means when measuring, you must put your object here. But if you are given a question in an exam and then you are asked to find the length and then they put their object at 1 here, what you do is get the final reading, which is 2.7, and subtract minus the initial position, which is 1.7, or 1.0, which will give you 1.7. And this will be the actual length of this object. The other precaution you must take, which is the last one, is avoiding parallax errors. Now, it is very important that when viewing this object to be measured, you do not view it in the sides like that. This object to be measured must always be viewed in line with the meter rule. This is what we call parallax errors. So avoid such errors when looking at the meter rule. And by so doing, you'll be able to get good, precise, and accurate results of your measurement. Let us look at our second instrument. Now, boys and girls, our second instrument in this video will be the Vernier Calipers. A Vernier Caliper is also a device that is used to measure length. But this device, it is used to measure internal and external diameter of hollow objects. A hollow object is an object that has got a cylindrical shape. So anything that has got a cylindrical shape can be measured, its diameter can be measured using the inward jaws of these Vernier calipers, and also the external diameter using the outward jaws. Now, how does this Vernier calipers look like? This is a rough sketch of a Vernier calipers. So, this is just a rough working. These are called the outward jaws, And these jaws are used to measure the external diameter of the whole object. So let's say you have your cylinder. You put it inside here and then it will be clocked outside there to measure its external diameter. If you want the internal diameter, you put the cylinder in and then measure the external diameter using these inward jaws. So a vernier caliper is used to measure the diameter of hollow objects, hollow or cylindrical objects, e.g. pipe, etc., etc. Now, what are the processes, or to begin with, let us look at the precautions you must take, or maybe let us first look at the steps you must take to read a measurement on a vernier caliper. Now, if you have been given in an examination question, they will only give you two parts. They will only give you the scales on these calipers. But I'm going to illustrate this using two examples. One which will contain a full vernier calipers. So this scale here does not move, and it is called the main scale. Then this scale is a movable scale, and it is called the vernier scale. So in examination questions, they'll only get this part. So I want you to keep this part in mind. And then there you have another scale. Let me put the scale there for more understanding. So if you are looking at it from this point of view, what will happen is that when you place your object there, you begin to adjust, and then it will give you two readings. One reading will be from there, which is the vernier scale, which is this one, and the other reading will be from the main scale, which is this long scale there. So if you are using this, you take the measurements from here of the main scale, and if you are using this, you get the measurements here for the what? For the vernier scale. Now, how do we do it? Let us illustrate this using this example. Please keep in mind that when you are using a vernier calipers, you can use two types of corrections, or I would say it is calculated using the precision or the accuracy of 0.01 centimeters. So keep in mind that if you are using a vernier calipers and they have given you in centimeters, what you have to use is 0.01. But if they give you these vernier calipers in millimeters, it will be 0.1 millimeters. I hope we're clear. So please don't forget these two. They will really help you in the exam or in any calculation involving the vernier calipers. Now, this has been given in centimeters, so we'll use 0.01. Now, keep in mind that this 0.01 is only used on the vernier scale and not on the main scale. So let us take the reading on the main scale. How do we do it? For us to find out the reading on the main scale, we check this Vernier scale. We can see that this Vernier scale starts from this point. So at this point where this Vernier scale starts, we'll check on top here. What is the point on this main scale? Remember, I'm trying to find the reading here. But for me to get the reading, I have to go where this Vernier scale starts from and then check the reading. So we can see here that we have 10. It means this is 9, 8, 7, 6, 5. This is 5.5. So in an examination question, you may be given options that are not 5.5 or rounded off, but you must round it off and then give a rounded off figure. But in this case, we'll use what? 5.5 centimeters. So this is our reading on the what? On the main scale. Then on the Vernier scale now, we'll get the reading from where the two lines align. These lines. So there must be a line down on this scale and on this scale which are going exactly in the straight path. So if we check this first line, no. But we can see that this line starts from there, ending up to there, right? So this is at 10, 11. So we have 11 centimeters. So now what we do to this Vernier scale is multiply it by its what? By its precision there. Now we can see that it is in centimeters, and so we use 0.01. We would have used 0.1 if it was in millimeters. Now if we multiply 0.01 times 11, what we get there is 0.11, I presume, centimeters. And then after getting that now, we will now add this value and the reading on the main scale. So that will be 5.5 plus 0.11, which will give us 5.61 centimeters. And so we have our reading there. It is very easy to take up the reading on this Vernier scale. Now, what are some of the precautions you must take when handling this device? Number one, always make sure that it is on its zero reading to avoid the zero error. Number two, you must clean this instrument before using it. And so with that, we end with the Vernier calipers. Let us conclude this video by looking at how we use the micrometer screw gauge and how and what objects does it measure. Now the micrometer screw gauge is another instrument that is used to measure length. Particularly, this instrument is used to measure the thickness of very tiny objects, and this is more accurate than the Vernier calipers. This device is used to measure the thickness of hair, razor blades, wire, as long as it is very thick that it can be measured using this device which is called a micrometer screw gauge. And this screw gauge has got an accuracy of 0.01 millimeters. So this only has one accuracy, 0.01 millimeters. For the Vernier calipers, it has got two, 0.01 centimeters and 0.1 millimeters. So that should tell you to say a micrometer screw gauge is mostly or usually produced with this accuracy of 0.01 millimeters because it is very small and it measures very small lengths. Now let us look at the typical diagram of this. So this is how the device, the micrometer screw gauge, typically looks like. Now you understand that it also has got two scales. This here is the first scale, which is called the circular scale. And this here is called the main scale. This here is what is called the sleeve. This here is what we call the thimble. This here is called the ratchet. The ratchet is used to adjust the position of the object. So we can see that we have our object there. So we'll be adjusting it until it fits perfectly. How do we know that it has been fitted perfectly? It is when it makes a click. So it will make one click sound. Then here we have the object to be measured. And then there we have what we call the anvil and spindle. So typically, if they ask you the functions, the ratchet is used to adjust the position of the object, while the anvil and the spindle are used to hold the object to be measured. Now, if you are looking at measurements involving a micrometer screw gauge, they'll only get this part which contains the scale, basically the same as the Vernier calipers. So, here's how a question might be phrased. So, for this scale, this is the main scale which you start with finding the reading for. Now, keep in mind that if you have been given a 0 here, this moves in 0.5. So if this is a 0, this is a 0.5. 1, 1.5. 2, 2.5. So the main scale will have a reading of what? 2.5 millimeters. While this other scale, which is called the circular scale, the reading is gotten from where this line passes on this scale at this point, which is a 5. So we have 5 millimeters. So what we do is multiply it by its accuracy, which is 0.01. Then we get 0.05 millimeters. And then we'll do the same and add this 2.5 on the main scale and this 0.05 and get 2.55 millimeters. Keep in mind that it may not be as straightforward as this here. You may have your 0 there, and then you may have your 3 there. It means you have 4, 5, 6, it ends at 6. So it depends on how you're counting or how your scale has been given. And then for this side as well, you can be given something like 0 there. It means you have 0, 0.51, 1.52, 2.53. It means you have a 3 there, but you don't multiply it by 0.01 because this is not the what? The main scale. Finally, instruments like the engineer's calipers, which look like this, can also be used to measure the internal and external diameter of hollow objects. But the best is the what? The Vernier calipers. And then a measuring tape will be used to measure things like the waist and so on. And so basically, that is the topic measurement of units. In the next video, I shall explain how we use the simple pendulum to measure time and also how we can use different other instruments to measure the amount of time that has passed, like a stopwatch and the stop clock.